ሰላም የቻናላችን ተከታታዮች እንደምን አላችሁ? የ9ኛ ክፍል ፊዚክስ አዲሱ ካሪኩለምን ዩኒት 3 ሞሽን ኢን a straight line በሚለው ዩኒት ውስጥ ዲስፕሌስመንት የሚለውን ሴክሽን ይዘንላችሁ ቀርበናል። እንደተለመደው ቻናላችንን ሰብስክራይብ፣ ላይክ ኤንድ ሼር እያደረጋችሁ እንድትከታተሉን እንጋብዛችኋለን። What is displacement? When an object moves, it changes its position. This change of position in a certain direction is known as displacement. A displacement is described by magnitude and direction. So, displacement is a vector quantity. The other point is displacement is independent of the path length taken. If you remember, distance is dependent on the path length taken. But when it comes to displacement is independent of the path length taken. Let's see an example. You travel from your home to school. Again, after school, you travel to your home. Therefore, the change in your position when you return back to your home is zero. So, in this case, we say that your displacement is zero. But when you consider the distance, we must sum. We have to sum. First, the distance that you are traveled from home to school, then from school back to your home again. In case of distance, the distance is the total path that you traveled. But when it comes to displacement is a change in a position. Starting from your home, when you go to school, there is a change position. But when you come back to your home, your change in position is zero. Relative to your home, there is no change. You are at your home. In this case, we are going to say that the displacement is zero. Like distance, the SI unit of displacement is meter. You know, the SI unit of displacement and the SI unit of this is the same, it is meter, but their basic difference is displacement is distance plus direction. So displacement is described by magnitude and direction, but distance is described by magnitude only ማለት ነው። To make it clear the difference between distance and displacement, let's see figure 3.3. Figure 3.3, it is an illustration of distance and displacement. Okay, let's consider the distance between point A up to B. Here again, point A up to B. You know, a car starts from point A, then travels the entire road, even the circular road the car travels, then back, then travels and it reaches B. So the overall this road trip, the overall distance, the overall road trip is called distance. But when we say a displacement is the shortest distance that is from point A to B. You know, if someone or if a car starts from point A to reach point B, there is two possibilities. The first one is the shortest way from A to B, that we call it the displacement. But the longest journey, the total path, or the entire road trip from point A, the entire road trip from point A to B is that we call it, you know, distance. So the key concept here is when you talk about displacement, it is change in an object's position. So generally there is a basic difference between displacement and distance. So let's see the difference between distance and displacement. So table 3.1 in your textbook shows that the basic difference between distance and displacement. When you talk about distance, it is the length of the path traveled by an object in a given time. But displacement is the shortest distance between the initial and final position. When you talk about distance, it is a scalar physical quantity, but displacement it is a vector quantity. When you talk about again distance, it depends on the path followed by the object. But when you talk about displacement, it depends on the initial and the final position of the object, but not necessarily on the path followed. The other difference is distance, it can be more than or equal to the magnitude of the displacement. When you talk about distance, it can be equal to or more than the magnitude of the displacement. But when it comes to displacement, its magnitude can be less than or equal to the distance. Here, in general, table 3.1 shows the basic difference between distance and displacement. I hope you understand the basic difference between distance and displacement. Again, to make it clear the difference between distance and displacement, let's see an example. Let's work with an example. Example 1. A cyclist rides 3 kilometers to west and then turns around and rides 2 kilometers east. A. What is her displacement? B. What distance does she ride? C. What is the magnitude of her displacement? To solve this problem, first let's have the given. When you solve problems in physics, the first thing that you have to do is you must have a given. Let's write our given. The first given is a cyclist rides 3 kilometers to west. This is a magnitude and direction. So 3 kilometers to west is a displacement. So the first one is the initial displacement. The initial displacement. So let's write like this. This is the initial displacement. The initial displacement is 3 kilometers. 3 kilometers. And then turns around and rides 2 kilometers east. So the final displacement is 2 kilometers. 2 kilometers. 2 kilometers. 2 kilometers to where? To east. 2 kilometers to east. The first 3 kilometers is to west. So A, what is her displacement? A required what? Required in A is displacement. Displacement is change in position. Change in position. Change in position. How we are going to solve this problem? Solution. Our solution will be, as you know that change and displacement, change in position or displacement is equal to final position minus initial position. What is the final position? The final position is 2 kilometers. 2 kilometers. 2 kilometers to where? To the east direction. to the east direction, minus to show as east is a direction, you can put arrow at the top, to direction to the east, minus 3 kilometer through 3 kilometer to the west. To the west, you can put an arrow again. So what will be the result here? The result is minus 1 kilometer. Minus 1 kilometer. Minus 1 kilometer. So here, as I told you, as I told you, one-dimensional motion takes place in the x-axis. This is x-axis. By having 0, 0 reference coordinate, which is found to the right or to the east is positive. The change in position is positive, and it was found to the west, which is the negative one. So the result here is negative 1 kilometer. So negative 1 kilometer. 1 kilometer means 1 kilometer. 1 kilometer to the negative x-axis, which is to the west. To the west. Here, if the east indicates positive, the west will be negative. So in general, the displacement of the cyclist is 1 kilometer to the west. Let's solve B. B, what distance she ride? B, the distance. Now, distance is represented by S. You can call it the total distance, ST. ST is S1 plus S2. S2. The difference between distance and displacement is the same, but its difference is direction. So here S1 is what? The first distance covered by the cyclist is S1. S1 is 3 kilometer. We don't need the direction because we are trying to find the distance. 3 kilometer. 3 kilometer. And S2 is S2 is 2 kilometer. Here we don't need, or we don't care about the direction because distance is a scalar physical quantity. So ST, S total, or total distance, or you can call it S. ST, you can call it S. So this is S1 plus S2. So S1 is 3 kilometer. S1 is 3 kilometer plus S2 is 2 kilometer. When we add it, what we get is 5 kilometers. This example clearly explains the basic difference between distance and displacement. When you talk about distance, we are talking about the entire journey, but when you talk about displacement, we are talking about changing position. When you talk about changing position, there is direction. This change in direction takes place in x-axis plane. So when you consider the x-axis plane relative to the origin of the x-axis at a point where the y-axis passes, which you call it 0, 0 coordinate, the coordinates that you get right to the origin of the x-axis, you can call it east direction. It is an east direction. Its magnitude is positive. And when it comes to the left of the origin of the x-axis, which is the 0, 0 coordinate, it is the west direction. Its magnitude is negative. You have to consider these things. C says What is the magnitude of her displacement? C is the magnitude. Now, as I told you, 1 kilometer to the west is displacement. West is, it indicates the direction. Direction on the west. But the magnitude is 1. So the magnitude of the displacement is 1 kilometer. Having the theoretical concepts, this example shows that the basic difference of distance and displacement. From the example, what you are understand is displacement is a change in position. In short, displacement is distance plus direction. Displacement is the shortest path, but distance is the entire journey. ለዛሬ ይዘንላችሁ የቀረብነው ይህንን ይመስላል። በቀጣይ ቪዲዮ 3.2 የሚለውን ሴክሽን ማለትም average speed and instantaneous speed የሚለውን ሴክሽን ይዘንላችሁ እንቀርባለን። በዚህ ሴክሽን እስከምንገናኝ ድረስ መልካም ጊዜ ይሁንላችሁ። እየተከታተላችሁ ስለሆነ እናመሰግናለን።